So we're back on the definition of the derivative, okay? Eyes on your paper. Definition of the derivative. Remember how we looked at this at the very beginning when we started derivatives, okay? And we said we were going through all this stuff, had to go through the process a few times because this is going to come up. There's a lot up here at the top that we're not necessarily writing stuff on, but you need to pay attention to it. It's not that complicated, but you can get things mixed up. So it reminds us, because we know this, that derivatives allow us to determine rates of change. What's another word for rates of change? Slope. Okay, slope at an instant by applying limits to the knowledge, because our derivatives really just are limits, right? So this is the definition of the derivative. The derivative of f at x is given by this. So f prime of x equals this limit, provided the limit exists. So we know that. We've gone through that. So you're going to see problems or questions where it's set up for you, and then you have to be able to tell things from it. Okay, not that we're substituting it in, working through it. You're not going to have to work through it and do all that crazy algebra. Just if you have this, the limit as h approaches 0 of sine of x plus h minus the sine of x all over h. Okay, so this is f of x plus h minus f of x. Does that make sense? So you need to be able to look at this and know from this that f of x is sine of x. Okay, that makes sense? Because this is the sine of x plus h minus the sine of x all over h. So then when we take the derivative of this, what's the derivative of sine? Cosine. So then f prime is the cosine, which means that the answer to this, if I substitute in 0, I don't get an answer that I get to use, but knowing what this is telling me, I get that my answer is cosine. Okay? You can see these in 3 different ways. Cameron, sit up. And so you have to understand that they are different and be able to pull out of it what you need. So this is just the derivative at x, right? This is the derivative of f at x equals a, meaning that we're going to evaluate it at something. So f prime of a, the limit pretty much looks the same, right? But this is our alternate definition of a limit. You notice here I have the limit as h approaches 0, limit as h approaches 0. This is the sine of x plus h. This is the sine of pi thirds plus h. So what has happened here is pi thirds has already been substituted in for x, because the sine of pi thirds is the square root of 3 over 2. Okay? So if you have the limit as as h approaches 0, if you have an x in there, then it's just the sine of x. You just pull it off from right there. If you have the value that's already put in there, then it's still just the sine of x. This here, f of x, is still just the sine of x. But you see the difference in the question. So if I want to know what this equals the cosine of x. This equals, well, f of x is sine of x. That's what we get out of that. When we take the derivative, we get f prime of x equals cosine of x. And then, since it was substituted in here, we need to evaluate it at pi thirds. So f prime of pi thirds is equal to the cosine of x. It's equal to cosine of pi thirds. And what is the cosine of pi thirds? Okay. So this one up here gave me an equation because we weren't evaluating it anywhere. This one gave me a number because I'm actually evaluating it at pi thirds. Yet another way you could see it, instead of saying h as h approaches 0, is the limit as x approaches pi thirds, or x approaches a number. So if it's not an h here, if it's an x, then you just grab your function from that right there. So, and again, if we substituted it in here, we'd get 0 in the denominator, so we can't just do that. We look at this and we know that f of x is sine of x. We get the same thing right there. Then we take the derivative, and then we would evaluate it at pi thirds, and our answer would still be 1/2. We'd get the exact same answer. So there's 3 different ways to look at these. Notice the differences so that you can, it's very important that you can look at this and take the function out of it. That's the main part of what we're doing today. So if you have x's and h's, there's your function right there. If you have h and a value, then it's whatever that value plus h is. You kind of take it out of that. And then if you have x approaches something, then this first part is your function. Okay, you see the 3 differences there? 3 different ways we could look at it. So let's look at an example here. This one, so we have to recognize that they all kind of look like, you know, they're set up the same way. You got a fraction, it kind of looks like it. You should be able to hopefully recognize that. So the limit as h approaches 0 of all of this right here. What would f of x be here? Cosine of 5x, right? Because this is your cosine of x, this is your cosine of x plus h. So then I need the derivative, because I pulled the function out, but remember this equals the derivative, so f prime of x is equal to, what's the derivative of cosine? Negative sine of what? 5x. You do not touch the argument. Is that it? No, times what? 5. So really, this is going to equal then negative 5 times the sine of 5x. Okay. What questions do you have? All right, so I want to know what this equals. The first thing I'm going to look for is, what is f of x? What is f of x in this one? Sine of x, okay? Just get it right from there. It's the sine of x, which means f prime of x is equal to cosine of x. Now, my answer isn't cosine of x because I need this as x approaches pi halves. So I have to do f prime of pi halves. And the cosine of pi halves is what? So my answer is 0. Do you see the difference in these two questions? Why one gives you an equation and one gives you just a value? Because we evaluate one, we don't evaluate, we wouldn't know what to evaluate this one at, but we know what to evaluate this one at. We good? Questions? Okay. So let's look at C. What do you think f of x would be? Well, f of x is going to be an equation. It's going to be a function. It's going to be the sine of x. It's going to have x's in it. Okay. So then I take the derivative. F prime of x equals what? Cosine of x. Do I evaluate this one? Yes. What do I evaluate it at? Pi 6. So f prime of pi 6 is equal to the cosine of pi 6. What's the cosine of pi 6? Square root of 3 over 2. What questions you got? Okay. So on D, I have the limit as x approaches 2 of this function right here, which looks a little bit less like a limit, like a derivative function than these do, but it still is. What do you think f of x is here? 2x cubed. F of x is 2x cubed. You just take it from there. Okay. So then f prime of x would be equal to what? 6x squared. Do I evaluate this one? Yes. At 2. So f prime of 2 is 6 times 2 squared, which is 24. What questions you got? All right, you try the next one. Finish it up. Is this one where do we evaluate this one? Okay, let's start. Y'all started this, everybody started off, okay. What's f of x? Tangent of x, okay. What's the derivative of tangent? Secant squared, okay. Beautiful. Do I evaluate this one? Yes. If this right here, if I have something plus h and it's not an x, we're evaluating at that value. So f prime of pi fourths is equal to secant squared of pi fourths. What's secant the reciprocal of? Cosine. What's the cosine of pi fourths? Square root of 2 over 2. So you can't just do 2 over the square root of 2 squared if you don't just remember what secant is, right? Because it's okay that it's not rationalized. We're going to square it. We end up with 4 over what? 2, which is 2. Okay. You can get to, if you know that the secant is square root of 2, then you square it and you get 2. It's the same way. Just if you don't remember that, you could just literally flip cosine and then, yeah, it's fine. I would hope that you would know it's square root of 2, but again, if not, I just did it that way. All right, what questions you got? Okay. So let's try G. What would f of x be from G? E to the x, yes. E to the x. So then I take the derivative. What's the derivative of e to the x? E to the x. Do I evaluate this one? Yes, because if as h approaches 0, this would be e to the x plus h minus e to the x, and x is 2, so I have to evaluate it at 2. So f prime of 2 equals e squared. And guess what e squared is? E squared. Bless you. Okay. Ask me a question. You understand where everything's coming from? You sure? Okay. Well, then let's look at h. What's f of x in h? 1 over x. So f of x is equal to 1 over x. You find the derivative. What's the derivative of 1 over x? What would you do here? You can work this 2 different ways. Could you use the quotient rule? Yes. Is there another way we can do it? We rewrite it. I'd rewrite it. Is x to the negative 1? So this becomes negative 1 times x to the what? Negative 2 power, which is negative 1 over x squared. Do we evaluate this one? As x approaches 2, yes. So f prime of 2 is equal to negative 1 over 2 squared, which is a negative 1/4. All right. What questions you got? Fairly simple, but do you see how they're all just like a little bit different where you could get mixed up in some things? So make sure that you can, think through them correctly. All right, so I'm going to give you your assignment. I think you should be able to finish this, and the answers are on the back so that you can check yourself, but let me know if you have any questions.